All right, this is your Stat Sensei, Mr. Spensei. This is scenario 5 of the take-home quiz. It's 2010 question 3. A humane society wanted to estimate with 95% confidence the proportion of households in its county that own at least one dog. Interpret the 95% confidence level in this context. So this says confidence level. And notice we don't have an interval. They just said, hey, 95%. We want you to interpret that. All right, it says in repeated sampling, we would expect that on average, our method would capture the true population proportion. The reason it's proportion is because they said proportion here of households that own at least one dog 95% of the time. All right. Sometimes it helps to define our P because let P equal the true population proportion of households that own at least one dog, because that's what we're stating here. Sometimes just doing the definition first might help with that, but was not required. So the Humane Society selected a random sample of households in its county and used the sample to estimate the proportion of all households that own at least one dog. The conditions for calculating a 95% confidence interval for the proportion of households that own at least one dog were checked and verified. That tells us we don't have to do it. And the resulting confidence interval was 0.417 plus or minus 0.119. So, a National Pet Products Association claimed that 39% of all households owned at least one dog. Does the Humane Society's interval estimate provide evidence the proportion of dog owners in its country is different from the claimed national proportion? All right. So the claimed national proportion is 0.39. We ended up with this. Well, what does that mean? Well, they gave us was 0.417 plus or minus 0.119. Well, this is my p hat right here. This is my margin of error. So if I add them together, I get 0.536. If I subtract them, I get 0.29. So essentially my interval is 0.298 to 0.536. And what are we? Well, in this case, they did a 95% confidence interval. So we're 95% confident that the values lie within here. Well, we're 95% confident the true population proportion of households that own at least one dog lies within this interval. And when I have to answer the question, and the question was, does the Humane Society interval estimate provide evidence? So I have to using the interval, is there enough evidence that it's different? Well, because 0.39 lies within the interval, we do not have enough evidence to suggest that the 95% interval that the proportion of households that own at least one dog is different from the Humane Society claim, right? So we can't claim that there is a difference, all right? Or from the National Society's claim. Next thing, how many households were selected in the Humane Society sample? Well, I always write down my formula, p hat plus or minus z star p hat times 1 minus p hat over n. This part right here represents the margin of error. Again, once we write the formula, we should cross it out. I plug in. Well, what's p hat? Well, first off, they gave me a margin of error of 0.119. There it is. This part right here has to equal 0.119. And we know that p hat is 0.417, so I plug it in. This is a 95%, so I need to go second vars, inverse norm, parenthesis 1 minus 0.95, close parenthesis, divide by 2. All z's are 0, 1. There's my 1.96. So if I take the 0.119 and divide it by 1.96 and square it, that'll take care of this part right here. I multiply 0.417 times 1 minus 0.417. and I divide that by what I just previously got, 65.95. So they need to do 66 households. If you are not confident using the formula, you can memorize this formula right here. N equals Z star squared, P hat, Q hat, margin of error. So in this case, what you would do is you go, well, Z star we said was 1.96. 1.96 times 0.417 times 1 minus 0.417 over 0.119 squared. And if I did that, I would get the same answer. All right. So I don't like memorizing that formula. I rather, since I have to memorize this formula, I use it. But that might help you out. So let's try it out. So I'm going to do the denominator first, 0.119 squared. Okay, we got that. Now 1.96 squared times 0.417 times parenthesis 1 minus 0.417, close parenthesis, gives me some value. I'm going to divide that by what I got here. And I made an error. As I said, I don't like doing it at all that way. But if you do it correctly, it should work. I'm not sure what I did wrong here. Try one more time. 1.96 squared times 0.417 times parenthesis 1 minus 0.417, close parenthesis, boom. Divided by 1, oops, 0.119. There we go. Don't know how I messed it up the time before, but there you go. That's how you approach it. Don't like doing the problem that way. All right. Well, that takes care of that question, and I hope you stay tuned for the next one. Thank you.